Well, all right, ladies and gentlemen, mathematicians of all ages. All right, we're working on solving systems of equations. And we've looked at solving systems of equations by graphing, and we've looked at it in terms of substitution. And now we're going to look at solving systems of equation by elimination using addition and subtraction. And so what we're going to want to do is we're going to have obviously two equations. There's our system of equations. And we're first going to want to eliminate one of the variables. Second step, we'll solve for the other variable. Once we have solved for the other variable, we'll plug it back in to one of the original equations and solve for the second variable. So let's take a look at what we're talking about. So let's say that we've got a system of equations. We got one equation that is x plus y equals -4. And our second equation is x minus y equals 2. All right, and what we're going to look at on this slide is using addition. Now, I can see that if I added these two equations together, this y and this y are going to cancel. Plus y minus y is going to give me 0y. And that's just what we're talking about when we say elimination. So now I'm just going to add these two equations together and solve for x. So I've got 2x, x plus x equals 2x, plus y, negative y equals 0. And then we've got -4 plus 2 is going to give me -2. I'm going to finish solving for x by dividing by 2 both sides, and x is equal to -1. Now, I'm going to take this value for x, this -1, and I'm going to plug it back into one of the original equations. And I think what I want to do is I'm going to plug it into that one right there. So let's do that. So I'm going to substitute -1 for x in this top equation. So I got -1 plus y equals -4. And to solve for y, all I've got to do is add 1 to both sides, and y is equal to -3. Now this is how I'm going to express my answer. I'm going to put the value for x first. I'm going to write this as an ordered pair, because remember, systems of equation, these are linear equations, and what we're solving for is the point of intersection between these two linear equations on a graph that would be on the coordinate plane. So I've got an x value of -1, and I've got a y value of -3, and that's my answer. Let's see, let's look at one more. All right, let's see, we've got 3x minus y equals -9. And then in my second equation, I've got -3x minus 2y equals 0. Okay, now, once again, I can see that I can eliminate, if I add these two together, I can eliminate the x variable, because 3x negative 3x is going to give me 0x. So this is the variable I'm going to eliminate by adding. And let's see, so now I've got -3y, well, change colors on us, equals -9. And I'm going to divide by -3 to both sides, and y is equal to 3. All right, now I'm going to plug this value for y into one of the equations, and I'm going to pick this top equation. I got a couple of reasons why I want to pick this top equation. Right here. Okay. I'm going to stay with the red. All right. So I'm going to write it like this. Now I've got, solving for x, I've got 3x. I'm going to write it right here. Now, even though y equals 3, this is a negative y. So I'm going to keep that minus sign. I'm going to keep that negative sign and plug in the 3 for y. So now I got 3x. I'll make that look like an x, I suppose. -3 equals negative 9. I'm going to add 3 to both sides of the equation. It's going to give me 3x equals negative 6. And when I divide both sides by 3, x is going to equal negative 2. Now, there's a couple of reasons why I chose this particular problem. One, you got to keep that sign in front of the value that you're substituting for y. Just because that's at y is equal to a positive 3, when I put it in this second equation, I keep that negative sign like it was in the top equation. Also, how I'm going to write my answer. I got to make sure that I write my x coordinate first. And so I said that x equals negative 2, comma, y is equal to 3. Boom. There is my answer. All right, well, now we got a dreaded word problem. So let's read this. We said that Rima is older than Ken. The differences of their ages is 12, and the sum of their ages is 50. Find the age of each. Well, the first thing I'm going to do, I see that we've got Rima and we've got Ken. And so I'm going to establish some variables. I'm going to say that R, small case r, terrible r, isn't it, equals the age of Rima. And K equals the age of Ken. All right, now in looking at that, next step is going to be I need to set up an equation for each. So let's read this second sentence. The difference of their ages is 12. So that I can then say that R minus K equals 12. The difference of their ages is 12. And then to continue to the last half of that second sentence, it says that the sum of their ages is 50. So R plus K equals 50. All right, now, looking at my systems of equation, I can see that I can add these. And when I do, I'm going to eliminate the K. I'm going to eliminate the K variable because I want to eliminate one of the variables first and solve for the second variable. So let's do that. So now we got 2R equals 62. 12 plus 50 is 62. Then I'm going to divide both sides by 2. And so R is equal to 31. So we're saying that Rima's age is 31. Now, we're going to substitute 31 in for Rima's age into one of the two equations. I like this top equation here. Looks like it'll be an easy one to do. Well, either one would be pretty easy. I tell you what, let's do the second equation. That way I don't have to divide by a negative number. All right, so I'm going to plug in 31 for R plus K equals 50. Now I'm going to subtract 31 from both sides. And when I do, 50 minus 31 is going to give me 19. So K, Ken's age, equals 19. So Rima's 31, Ken is 19. Boom, we have solved the hideous word problem. All right, fellow mathematicians. Now we're going to use elimination using subtraction. And of course, you're going to see the way I do it, I'm going to end up adding them anyway. But let's just get straight to the point here. All right, I've got one equation, which is 6x plus 5y equals 4. And then my second equation is 6x minus 7y equals negative 20. Now, when I look at that, well, I can't eliminate the x's right away because it's 6x plus 6x. And on the y's, it's plus 5y minus 2y. So I don't have anything that I can eliminate straight away. But what I can do is subtract these two equations, what we call subtract these two equations. But I want to show you how I do that. Actually, if I subtracted the two equations, it's going to change the sign of each of the terms in that second equation. Now, what I like to do is I like to do it like this. I like to just think about multiplying all this equation by -1. And so when I do, that's going to change that positive 6x to a negative 6x. That negative 7y is going to become a positive 7y. And that negative 20 is going to be a positive 20. Reason why I like to do that, if I'm subtracting it and I got to think about, well, I got to change the sign, I got to change the sign, I got to change the sign, I got to think about that 3 times. Well, that's a good chance I'm going to mess up on that. So I'm going to rewrite these 2 equations. And I'm going to say it's 6x plus 5y equals 4. This equation is exactly how it appeared. But when I rewrite the second equation, now I've got negative 6x plus 7y, negative negatives plus, equals positive 20. Because it's going to change the sign. It's going to change the sign of every term. And now really all I'm really going to do is just add them. So I got 5y and 7y is 12y. And 4 and 20, is 24. And guess what? Y is equal to 2. Now, just like I did before, I'm going to substitute in this value of 2 for y into one of the 2 equations up top and solve for x. It doesn't matter which one I do. And I'm going to go to the original equation, not where I modified that. So I'm not going to change that. I'm going to stick with that. In fact, let's use that equation. So then I would have 6x minus 7 times 2 equals negative 20. Okay, so 6x, negative 7 times 2 is negative 14, equals negative 20. And I'm going to add 20 to both sides. Add 14 to both sides. Add 14 to both sides. Add 14 to both sides. Add 14. Okay, you got the point. 6x is now equal to, well, negative 20 plus 14 is going to give me negative 6. Divide by 6 both sides, and x is equal to negative 1. And so my answer here then is negative 1, 2. Remember, I put my x first and my y second. And that's really all you got to do. So what you're doing when you're talking about, I don't know if I got time to do another one or not. All right, let's do one anyway. Okay, let's see if I can get it squeezed in. I got 3m. Let's change the colors. Let's see, we'll go orange. 3m minus 4n equals negative 14. And I got 3m plus 2n equals negative 2. Now, since I'm about to run out of space, I'm going to do a little bit of a shortcut here on you. So I'm going to look at this as I'm going to subtract all that. Means I got to change the sign of every one of those. So this positive 3m down here becomes a negative 3m. This positive 2n becomes a negative 2n. And this negative 2 becomes a positive 2. All right, now let's just add them. 3m minus 3m is 0. Negative 4n, negative 2n is going to give me negative 6n. That should be an n. And that's going to equal, let's see, negative 14 plus 2 is going to give me negative 12. I'm going to divide negative 6 to both sides, and n is going to equal 2. All right. Now I can substitute 2 in. I think I'm going to do that right up here. And substitute 2 for n in one of the 2 equations. It doesn't really matter which one I use. I'm going to use the second one. All right. So we got 3m plus 2 times 2 equals negative 2. And 2 times 2 is 4, so I got 3m plus 4 equals negative 2. Well, getting ahead of myself. Negative 2. Subtract 4 from both sides, and so I got 3m equals -6. And boy, I did run out of room, didn't I? M is equal to -2. Now, how am I write my answer? Remember, my first letter in the alphabet comes first. That's M. And so my answer is -2, 2. Boom. All right, if you have any questions, let me know. Ah, yes, another word problem. And I will confess, this was probably a little tricky, which is why I picked it. So this has to do with geometry, which probably none of you have had yet. It says here that two angles are supplementary. I'm going to stop right there. In geometry, supplementary means that they are equal to 180 degrees. So I'm going to just use x and y for my variables, and I've already got one of my equations written. In other words, x plus y equals 180. Okay, then the measure of one angle is 10 degrees more than 3 times the other. Now here's the tricky part. How am I going to set that up? I know I want an x and y variable. I know I want to set it up so I can solve it as a systems of equation. The measure of one angle is 10 more. So I could actually write this, let's see. I could say x, that's the one angle, and the angle that is 3 times the other is going to be 3y. No, and I got to use a difference here. Equals 10. So in other words, the measure of angle x minus the measure of angle y, which is 3 times the other, it's going to give me 10. Now let's just subtract these. Well, let's use our little trick here about -1. And so now I'm going to have x plus y equals 180. And -x plus 4y plus 3y, excuse me, getting ahead of myself again, equals -10. Let's just add those two together. The x and the -x are going to cancel. I'm going to be left with 4y equals 170. And if I divide 170 by 4, dividing both sides by 4, I'm going to say that y is equal to 42.5. You might want to check me on the calculator. All right, now that I have found a value for y, I can plug it into one of the original equations. I'm going to choose the top one. So now I've got x plus 42.5 equals 180. I'm going to subtract 42.5 from both sides, and I'm going to find that x is equal to 137.5. All right, now let's think about that. Okay, well, 42.5 and 137.5 equals 180. Those two angles are supplementary. And if x is equal to 137.5 and y is equal to 42.5, let's see, 42.5 times 3, putting in, say, 127.5, well, 137.5 minus 127.5 says that the difference is 10. Boom, done it.